Hi, my name is Lucas Weintraub, and today we're going to look at combinations and permutations. These are both very similar things, but sometimes they're hard to grasp, and most people don't know the difference between them. They're easy to get mixed up, and I'm going to show you the differences and how to calculate math with them. So, combinations and permutations are both tools that count the number of ways to do something. But the difference is that combinations only matters about what you count, whereas permutations matters what you count and the order that you count them in. So, for example, if you were to have a group of a blue, maybe this is ball number 1 and this is ball number 2, and another group like ball number 2 and ball number 1, these are both the same combination. This group and this group are the same combination. But they are different permutations because 1 is first in this one, but 2 is first in this one, so they're different permutations. Here are some examples that help with your intuition. So let's look at this example of colors. How many ways can you choose 2 colors? I'd recommend that you pause and try out. The answer is 3. So you could choose red and blue, blue and yellow, or yellow and red. And so this is what's called a combination because you're just asking for the combinations. If one of your choices was yellow and blue, those are the 2 colors you chose, it wouldn't be any different. But what if we ask the question, how many ways can you have a first favorite color and a second favorite color? I would try this yourself. The answer is 6. So it's just like the combinations, except you do count the ones that are different. So it's just, I'm gonna count all these groups. So this is blue and yellow, and this is yellow and blue. This is red and yellow, this is yellow and red, and this is blue and red and blue. And so these are my first favorite and second favorite color, first favorite and second favorite color. So you can tell that these are different permutations because here blue is my first favorite and here yellow is my first favorite, so they're different. Let's move on to another example. So this is another question that shows the difference between combinations and permutations. So ask yourself, how many ways can you make groups of 2 given 4 people? I would urge that you try out. And also, how many ways can you make a line with these 4 people? So there happen to be 6 groups or 6 ways, and you could count it just like the colors question. So it's just a way of counting. And then there are 24 ways to line up 4 groups of people. And this is because if you had if this was the red person, and you had the 2 people in the middle, and then this is the blue person, it would be a different order if they were flip-flopped. And so we count them as different ways. And that's why the number of ways for this question, otherwise known as the permutations, is much bigger than the combinations, because the combinations we get rid of all the ones that repeat. Oops. So a related concept is the idea of independent and dependent situations. So independent is when one factor or one situation doesn't affect the other, so it doesn't matter. But a dependent situation is when the aspect of one thing does change the other. So they're related. So if we were to look at maybe this question, make groups of 2, it doesn't matter if you look at a group as red person with orange versus orange with red. These are the same groups. And so these are independent because it doesn't matter which one you choose first. So that's an independent situation. This is dependent because the situation or the way to make a line does change whether or not a person comes first or last. And you can make the same argument with the color questions that we did earlier. So those are independent and dependent. Now we're going to look at formulas for how to compute when situations get large. For example, what if you had to choose the number of pixels on a screen, and like at random, that could be a lot because there are lots of pixels. And so we can work it out with these formulas. So imagine you have n objects. It could be like the 3 colors, and you choose k of them. So earlier we chose 2 from the 3 colors. The formula for that is going to be n factorial over n minus k factorial times k factorial. This can be written as n choose k, which is the same as this notation. And if you don't know what the factorial is, this is a quick tutorial. So 1 factorial is equal to 1, 2 factorial is 2 times 1, 3 factorial is 3 times 2 times 1, and it just continues. If we were to do 100 factorial, it would be 100 times 99 times 98, all the way down to 1. So if we were to, like earlier, maybe do choose 2 colors from a group of 3 colors, it would be 3 factorial over 3 minus 2 factorial times 2 factorial, which is 3 times 2 times 1 over 1 times 2. And this is 3. And we did in fact have 3 ways. Permutations, on the other hand, is a similar formula, but it just doesn't have this k factorial. This part is gone. And you can also write it as npk, kind of like nck. And sometimes this is a really difficult part. People don't know which one is which, like which one is a permutation, which one is a combination. And I want you to ask yourself, which is bigger? So combination or permutation? Which situation usually results in more ways to do something? Let's go over to the color situation. This situation is otherwise known as 2 choose 3, because this is a combination question, and we're choosing 2 colors from 3 objects. So that's 2 choose 3, and our answer for this was 3. This is 2p3, and our answer was 6. And so it shows that combinations are less than permutations, because we had the same numbers, 2 and 3, 2 and 3, but permutations have 6. And that's because permutations have more ways to do something, because if you change the order, those are different. And so you end up counting way more possibilities. But the combinations, you get rid of a lot of possibilities because several of them technically just repeat themselves. So we're just going to write this as permutations are bigger than combinations. And now look at this formula. Which of these formulas are bigger? So n factorial and k factorial, these are always going to be positive because for any number, it's going to be 3 times something, or just something all the way down to 1. And so that's going to be a positive number. And when you have a k factorial on the bottom times this just makes the bottom bigger, because k factorial is going to be something big. It's going to be bigger than 1 or equal to 1. And so that means the whole thing is smaller, which means that this is bigger. So the bigger situation corresponds to the bigger formula. So permutations is this formula, and combinations is this formula, because combinations are less, and this formula is going to be a smaller number for the same numbers n and k, and the same argument for permutation. And that's exactly what we have over here. So now we're going to do a quick quiz. So question 1, how many 4-letter words can you make from 4 different letters? It doesn't matter if it makes a real word or not. Just imagine that you have 4 letters, like I'm actually going to give an example. If you were to have L, A, K, and M, how many 4-letter words can you make? But I don't want you to ask yourself, or I don't want you to find the number. I want you to figure out if this is a combination or permutation. So pause the video to figure it out. And the answer is permutation. The reason why is if you make a word L-A-K-M, this is not the same as M-K-A-L. So the order matters because words in English have order of letters. Question 2. What is the formula for the number of combinations? So you could either memorize the formula for the number of combinations, or you could use the thought process that we went through above. Think about which one is greater. I'll give you a second to think about it. Try to answer on your own. And the answer is n factorial over n minus k factorial times k factorial, otherwise answer B. Lastly, let's do 3. This is going to combine all of our knowledge from before, and you're going to try to calculate the number of people, or the number of ways that you can count this. So the question is, a teacher wants to make one group of 3 from a class of 20 students. How many ways can the teacher make a group? So I would pause and maybe get a paper and pencil to do this, because you can't really do this in your head. And the answer is going to be C, 1,140. The reason why is the first step is to determine if this is a combination or a permutation question, and this is a combination. Because if we had a group of people named Alex, Kevin, and Veronica, it would be the same group as Veronica, Alex, and Kevin. So this is a combination question. Now we just have to plug in our numbers. So the formula for a combination is n factorial over n minus k factorial times k factorial. Our n is 20, because we have n total things, so 20 factorial. N minus k is 17, because 20 minus 3, so we have 17 factorial, and then times 3 factorial. One thing about factorials is you can kind of cancel out the numbers. We have 20 times 19 times 18 times 17 all the way down to 1. This is the same as 17 factorial. So we have 20 times 19 times 18 times 17 factorial over 17 factorial times 3 factorial. So this cancels out. What you're left with is 20 times 19 times 18 over 3 times 2 times 1. And you can just put this in a calculator or work this out yourself on paper, albeit it will take it longer. But your answer will end up being 1,140. I hope that makes combinations and permutations easier to understand. They're not that hard once you get some practice, and if you can understand the difference between them, it makes it a whole lot easier.